Hey guys, Mike V from Reliable Automotive Equipment here. Today we're going to be talking about the Jag Land Rover XPress 800 rivet gun. So we are going to set some rivets, punch some rivets out, do some flow forms, and go through the whole system of the gun. On the cart, a couple of things here going on. We are going to bring air into here. They have set their system up that we are going to be setting rivets by the KN pressure required by the repair procedure sheet, depending on what self-piercing rivet or flow form rivet is going into the project. So main air coming into here. This is an adjustable regulator for the settings on this that you can dial down. It will bleed down. And we can bring it back up to what we want to set to. So a couple things what this is going to be doing also. This is also an actual reserve air tank. So if you are in the middle of setting a rivet and for some reason you lose all air, there's enough air left in this to set your final rivet, and then it will shut down. So you're not stuck in the middle of setting one of the rivets. So air pressure coming out of the blue line on this side will get connected to the gun. All right, so Jag Land Rover actually required a new, what we call a short stroke cylinder. For the original XPress 800, this one has a little bit more tonnage rating on what they want to have for setting their rivets. So what they've done is bypass the pressure setting back here and the speed control on the back, and everything is going to be set up by the KN pressure on the cart that they have now. So what we're going to do is dial this red knob all the way up for full pressure, and the speed control knob on the back is going to be all the way out for speed. So we have full openings on this coming in, and now everything is dictated by the cart with the KN pressure that we're going to be setting on. So everything else on this is going to work the same way as the XPress does. So we're going to attach the blue hose into the back of it now. And right now I just have a 5mm self-piercing die set up in here that we're just going to set one in the panel. Okay, so we're going to be setting a 5mm self-piercing rivet into the panel. And this is not an actual off the repair procedure sheet, but we're setting our KN pressure around 50. And this will go into the magnetic area. Panel goes in. Machine does the complete set, what we're looking for. It's a good set on that. So any of the rivets that you're putting in on Jag Land Rover on the repair procedure sheet, they will tell you what rivets are going where, and with each one of the rivets, they will have a KN setting that you'll be setting up on the cart to make sure that it achieves the correct pressure. So in the die kit assembly that comes with the Jag Land Rover, what they have done is the self-piercing rivets that they're using on there, they have several of them set up on here. And their settings are the magnetic head for holding the rivet, and then the different style heads that are going to be closing on the rivet are listed in here as a PIP, a flat bottom, and a shallow. So this information will also be on the repair procedure sheet for what closing head to use on what specific rivet. So pay attention to repair procedure sheet. What's inside the box? As usual, all the dies are numbered, so if you're looking for one, you can pinpoint the exact one that you're looking for in case they get mixed up in the kit. So that is for setting of the self-piercing rivets. And what they have added onto this now is they are replacing some of the self-piercing rivets when they get pushed back out or extracted with a flow form rivet. So we're going to be going through the extraction process on a self-piercing rivet, which we change the head assemblies out on here. Make sure when you've got your hands in here and it's plugged in, this little lever here is flipped up. Usual protocol on this, when you are taking off or putting on the head assembly, this valve always needs to be in the up position. This is basically a on-off valve, like similar to a porta power. When it's turned on, you have pressure going through and it holds it. When it's open, pressure will not hold on either side. So when we go to load the head assembly or take the head assembly off on the gun, this is a newer style collar. For you guys that are not familiar with it, the older style had a lever on the back that you would turn and the head assembly would come off. This acts more like a hose coupler that we're going to pull down on this and the head assembly will come out on it. So we want to make sure that the lever is up. Hold the assembly before you release the ring because it is spring loaded, and we're just going to pull down on that and the head assembly will come out. If you don't keep this lever up, it's not going to happen every time that you don't have it up, but eventually you have a very good chance of blowing out the seal in the bottom of the cylinder. This is part of this relieving pressure on either side of the pump or the cylinder. So when we go to put it back on, we want to do the same thing. Lever up, pull down the coupler, put the head assembly in, listen to it click, and make sure that the ring clicks back up all the way in the top also. It's a much more simpler process, but if you don't hear that click going back up and you go to hit the trigger, possibility of popping the head off of the power unit. So when we go to change these out for pushing out the rivets, in the kit, so we have these two items here for pushing out. This gives a relatively good opening for the rivet assembly to get pushed out of. This has a longer point on it for pushing out, and this little piece of red Teflon will actually compress as it presses against the material, and this will actually help push the extractor piece back out of the material. When this gets compressed, it has about 1,000 pounds of pressure pushing back out on the tip coming out of the gun. So as usual on the XPress, when you go to put these on, you can put them on either way you want to put them on. So the little red piece can go here or here, and so you don't have to keep moving the gun all over the place. Unscrew. So we're just going to put the red piece down on the bottom. The extractor piece on top. And as usual on this, if you're putting a piece in and it's hitting the other piece, you can't get it straightened up, just open up the C-arm, let the C-arm move forward, get this past the obstruction, bring it back again, lock it back in. And as usual on these, all times, guys, always hand tight. Do not take the wrench and tighten them up, but do not allow a gap to be in there, because that is where all the die head assemblies are designed to take all the pressure on the head assembly, not on the threads. So if you don't have something threaded in so you have contact to the base of the head assembly, you will end up snapping the threads because it's not built to take that kind of pressure. So with these being snugged up, pushing out on the self-piercing rivets. On this, we're going to make sure we're going to bump our air up on this a little bit for pushing out. So on these self-piercing rivet, you're going to be pushing back the opposite way of the way that they went in. In the kit, there actually is a little self-piercing for going on the back side of the rivet that will fit right over top of it. Give it a little smack with a hammer. It'll make a center point in the back of the rivet. Makes it easier to find center on the red part. Do not try and put your rivet over the opening of the hole and then allow the red part to come up to it. You want to go ahead and get it right on the back of the rivet and let the gun assembly move forward to where the push out point is, so we're always in the center of the rivet. This will always be in center of the receptor piece up here. So by putting that in, lever back. On pushing out, I just want to show if I can kind of see how the red piece here works. So that piece expanding so much as it does, it's just putting pressure back on the die coming back. So as you're going to push these out, you do not have to over push this every single time. Once you hear the rivet just clicking going out, you guys get used to it, pushing the rivets out. No big deal on that. So we'll just throw one more in here again. Rivet is out. Any of the rivets that hang in there will end up falling out as you go along. And of course, there's the self-piercing rivet getting pushed out. So you're all pretty familiar with that. You guys have been using this. Now what we're going to be doing is sometimes you're going to be reforming the existing hole. Sometimes you're going to be punching a new hole in it if it's calling for a flow form rivet, whatever it calls for on the repair sheet. So we're going to take these pieces out and we're going to set up for what we call reforming the material. So when we have our pieces out on this, we got a couple pieces here in the kit that we are going to be using for reforming the material and then punching holes for the flow form rivets. So if sometimes you have the die goes in a little bit more harder than you think it should, there is a little O-ring on here to help keep this from loosening up. A little drop of air tool oil on here will make the world of difference of putting this piece in. It makes it go a lot smoother. So once we have this piece in, this little base plate right here slides right over top. So what we're going to do is we're going to reform our material. In reality, this would be the outer panel coming off of the vehicle. This would be the inner panel that's staying on there. When you're pushing out self-piercing rivets, it will do some tearing and deformation on the panel that's staying. It definitely tears up the outer panel that's coming off the vehicle. This is going to flatten them out as like a hydraulic press. If you go to hammer and dolly this piece back out, you're actually going to work harden the aluminum and it's going to create a crack around where the rivet goes. If we do a hydraulic press, it will literally press the material together and reform the aluminum structure in there. So what I want to make sure is that we're actually reforming the material that's staying on the car, which would be the inner panel. The outer panel will still be on the car itself because this becomes a sacrificial where any excess material, there is a 6mm hole in here, any excess material will go through that opening. So on this, you do not run the gun assembly all the way out. All we want to do is just enough to reform that inner panel. So we want to make sure that the center point is in the center of the hole. And that is what it's going to do, is flatten out that piece of material in the back. And it's actually making that opening a little bit more smaller as it pushes the material back in. So once this has been all pushed out, flattened out, now you can take off your outer panel, put on your new panel in place, and then punch a hole for the flow form rivet through the existing hole in the inner structure. So in order to do that, all we do is slide this piece off, and these are cutting rings. So this is a 6mm cutting ring that actually cuts on both sides, and it will fit right on the top of this. We can cut through existing material, we can cut through new material. The cutting ring is slightly bigger than the diameter of the shaft coming down, so that means that when this goes into the material and goes into the cutting head assembly, this cutting ring will stay up inside the head and this piece will retract back out again and it won't allow it to get jammed up. So going through new material, Cuts it super clean, super quick. The cutting head is off. It's actually up inside there. These are reusable. When you go to start cutting these things, these openings on the sides, they're going to fall all over the place. So take a piece of masking tape, put it around the hole, and you can punch out about a half a dozen or eight setups on it. Take the tape back off, put your rings back in the box, and keep on going. And they will cut on both sides also. So that is a new cut. This is existing in the panel. So I would be pushing through the existing panel plus the new panel on the other side. So depending on the technicalities in the sheet, if you have more distortion around the area than what is allowable for their program, you might have to put a new hole in the middle of it. It depends on what it calls for on the repair procedure sheet. What we're looking for is a nice clean hole on it that when the rivet goes in, it has 100% contact with all the material. So after punching the holes, now we're going to set a rivet on there. All right, now that we have a hole punched in the panel, a flow form rivet is going to be going in. So a flow form rivet is something that cannot be pushed through the panel like a self-piercing rivet can. This does need a hole punched in it. The technicality of this is it should be a punched hole because it becomes a pretty much perfect circle. If you drilled the hole for a flow form rivet, you are going to have not a complete round hole in there. On the flow form rivet, there needs to be a little bit of space in there, so when the piece gets crushed down as it moves out laterally, it will fill in that area so there's no voids in the material. So head assembly will go into the head assembly over here. There's a little center point in there that will go right into the center point of that. You can always tell the closing head on a flow form rivet because it has a hole in it to allow glue to escape when you're setting this. So all we're going to do with this is set it up against the setting assembly, and then the closing head will form that over. And what it has done was roll that edge over, and now it actually took that material and work hardened it, and this is actually a higher strength steel than before the rivet was set. The back part of it, that little pin that goes into the center, actually when that sets in there, does not set in there perfect. That pin actually continues protruding through that, and it hardens the back part of the rivet as well. So this is now a work hardened rivet that has been put into the panel, and this is a definite structural rivet when it's closed over on both sides. All right, so on the cart, this is designed that if there's an interruption in the air system anywhere, you're still able to set the final rivet that you're going to be doing. So with this still working fine right now, if this gets disconnected from the air supply, there's enough air reserve in here to completely set another rivet. When we go to do another one, does not allow us to continue on with the system. Then we're going to hold the reset button, give it a couple of extra seconds at the end, make sure that all that air is out, and then magically air comes back on again. All right, we are going to be going over the blind rivet head assembly for the Jaguar setup. On our setting over here, we are going to max this out. They actually call for 78 in the book, says it's the max part. Keep in mind your air inlet going in, there's max pressure on that is 8 bars, which is around 115 psi. So if you have a really high air pressure in your shop, you will need to get a reducer for this in so it doesn't damage anything with this system. So on 78 coming out, that's pretty much full power on the Jag Land Rover system. going over to the rivet head assembly, when we do a blind rivet, the reason why this thing can be maxed out at full power is the mandrel that pulls through to set the rivet is going to be the piece that is going to snap when it hits its preset limit of where it's going to break. When we are pressing a rivet together, a self-piercing rivet or a flow-form rivet, we have to control the amount of pressure to set that rivet. But on a blind rivet, you pretty much have maximum pressure set on the gun, and once this thing goes through, rather how big or how small this is, when it snaps off, it is set at its predetermined power. So blind rivet goes into the opening that you're looking for. Make sure that you're using the correct one, because if you don't have the correct diameter going into the hole that they're calling for on the material, you're not going to get a complete set on the rivets. So basically on the BR50 head, this is a 5-ton rated unit. This will snap the mandrel back, and the mandrel part will continue on back going into the pickup container on the back of it. So on this one, we just set into the material. The nose piece. These are laid out in 3. We started 3.2, 3.5, 4.0, 4.5. What this does, the nose piece going into the teeth assembly, this is one of the big issues. What this does is, as we sort these out on the smaller to the longest, this will be a smaller diameter, this will be a larger diameter on the piece going in, and then the length of this is longer, which is actually going to push the teeth down further, and the 3 teeth that are in there are set at an angle, so the further they get pushed down, the more that they open up to accept that size mandrel to come into it. So this sets up the proper setting of the teeth for the rivet to go into it, so the rivet can go in and not get stuck with the teeth with the spring tension on it. If you put this in without this piece on it, it'll just grab right onto it and you won't be able to pull it back out. So we'll put this onto the panel, put this into the head, and all this is going to do is just pull the piece. The nose cone is going to hold the rivet piece against the material, and then the mandrel is going to pull through. It's going to crush the back part of it, and once it breaks, that piece will drop right down into the back. So blind rivet is set. Back part shows it crushed over. It did the job what it was supposed to do, and that is it. All right, guys, that wraps up the Jag Land Rover Express 800 setup. As usual, if you have any questions, phone number's on the screen. Website is on the screen. Contact us for anything you need to know. Thanks, guys. Have a great day.